This video is going to include two sections, section 8.1, which is polar coordinates, and then we're also going to include within this time section 8.2. So section 8.2 is graphing polar equations. Okay, so we're going to start out with 8.1. When we have a graph that we've done so far, if I have something that looks like this, we say this is a coordinate axis, okay? But what kind of coordinate axis? Here's my x, here's my y. I have a point here that I start with called the origin. And if I have a point out here, x comma y would be its name. That would be its ordered pair, right? So to get to that point, though, I have to go over my x and I have to go up my y. So what does that form? That forms a picture of a rectangle, right? So this is called a rectangular coordinate system. Now, other than a rectangular coordinate system, it's also called a Cartesian coordinate system. And the reason why it's called Cartesian is because it's named after a mathematician, René Descartes. So when we have a rectangular coordinate system, we've got over x and up y. But as you've seen in the classroom, there's another kind of coordinate system that we have, and we call it the polar coordinate system. So I'm going to just bring some over and kind of let you see. So when we're talking about polar coordinate system, we're talking about a graph that looks like this. So there's a different way of finding an ordered pair on here than there is the way we find it on a rectangular one. So we'll come to that in a minute. So polar coordinates have something to do with a distance and an angle. So we have a distance and we have an angle for polar. So the polar coordinates look something like this. We said it was going to be a circle. This one's kind of small, but we're just using it for a little while. So we're going to have say I have r comma theta, that's what it, instead of x and y like we had up above, r is going to be the distance out and theta is going to be the angle that we're taking. So if this is pi over 4 and I put a dot 1, 2, 3 out from the center, from the pole, this is the pole and this is the polar axis. So the pole is that dot where we would normally call the origin. So r is the distance out, 1, 2, 3, and theta is the angle. So this would be the same thing as saying 3 pi over 4. So r is the distance out, theta is the angle that it's taking. Now, when we do something like this with polar and rectangular coordinates, the thing about polar is that there's more than one name for every point. There's actually an infinite number. Because we could go around and stop there, go all the way around and stop there, and just keep doing that forever. But what would be some of the ones that are just local, the way we have it? So 1, if we look at it, would come from here all the way around in the negative direction to get to that dot. So how many would that be? Let's draw the other one in. If this is pi over 4, and I'm going from here all the way to that pi over 4, how many pi over 4s are in the circle to begin with? 8 pi over 4 because we have 2 pi, right? So if I go backwards, this would be a negative what? 7 pi over 4. So another way of naming this is 3 comma 7 pi over 4. You're going negative 7 pi over 4, sorry. Negative 7 pi over 4, and then that's your positive side, so then you would count out 3. Now another idea that we could do that someone earlier talked about was, what about a negative 3, negative 5 pi over 4? So let's test that out and see if that works. The negative 3 is going to come from going backwards on the line. So negative 5 pi over 4, so negative 5 pi over 4 would be up to here, so that wouldn't work. But what if I used negative 3 pi over 4? So negative 3 comma negative 3 pi over 4. So this would be 1 pi over 4, 2 pi over 4, and then this one would be 3 pi over 4, right? So then what do I do? This is the positive side now, so to bring it back to here, I would have to use a negative 3. So negative 3 pi over 4, that would work. So here we have 3 different choices so far for the name of that angle, or that dot. All right, so now we're going to each of us draw a graph, let's say, that has 4 circles. So we're going to just draw one that has 4 circles. So we're going to do a little bit of a practice now. We're going to practice putting in some of the values. So I'm going to have point A is going to be 3 comma pi over 3. B is going to be 5 comma negative pi over 4. C is going to be negative 6, 5 pi over 6. Now, sometimes it helps to have a straight edge when you're doing these so that you can draw your lines a little better. So my one is going to go down the center. And then I have see if I can get my pi over 3 in here without it being too crooked. Okay, the ones when we get on the other ones will be a lot better here in just a little bit. But it's, like I said, just having a cardboard piece or something like that to make your straight edge. So we're going to do the first one first. This is our r comma theta. So the angle is pi over 3, and it says positive 3. So I'm going to go up to my pi over 3, and then I'm going to count out 3. 1, 2, 3. And that's going to be point A. And then I do B, negative pi over 4. So now the negative angles start here at 0 and go down to the left instead. So we're going to go down to the left, which would be the middle one. So this is the middle one. Doesn't really look like a middle one, does it? So this is my negative pi over 4. And then where's my 5 going to be? Looks like I should have drawn a bigger circle. So we're going to have, from that line, pi over 4, we're going to come out 1, 2, 3, 4, one more would be 5. And that's going to give me my B. My C is 5 pi over 6. So where's 5 pi over 6? 5 pi over 6 is right here. So we're going to make this be 5 pi over 6. And 5 pi over 6, we're going to go negative 6. So this is my positive side. So negative 6 is going to go left. So again, if it's kind of hard to see where your lines are, put a straight edge up next to them. So this would be the positive side up here. So the negative side is going to be down here. So we have negative 6. So 1, 2, 3, 4, 5, 6. And that would be my C. So we're okay with plotting the dots? All right, so now that we know how to plot the dots, we're going to take the graph and we're going to convert from one to the other, okay? So we're going to look at a picture first, and that's going to help us to know how to convert. Okay, so we've got r comma theta. R is the distance out from the origin, in this case the pole, and theta is the angle that you went, right? But if I drop this perpendicular, I also have an x and a y. So I can go x out and up y to get to this point. So we've got x, y for that point, and we've got an r theta. So that means that if I know the xy version, then I can find the r theta version. If I know the r theta version, I can find the xy version. So I'm trying to find, how do I do that? So we're going to look at some choices. When I look at this picture, I see a right triangle, some legs, and a hypotenuse, right? So we know that we have r squared equals x squared plus y squared. Now, where did that come from? Pythagorean theorem, right? So this would be one of my formulas, because this would convert x to y to r, x and y to r, because we could take r, take square root on both sides, and we'd have r equals x squared plus y squared. So that's another formula we can use. So if we're looking for r, we use the square root part on it. If we're looking for just r squared, then we leave it up. Now we have to also know something that's going to help us to find the x and the y when we know the r and theta. So we're going to look at SOHCAHTOA again. So we know that tangent of theta, it says, is TOA. So tangent is opposite over adjacent. So in this picture, there's theta. What would be opposite and what would be adjacent? So y over x. So we can rewrite that as theta equals inverse tangent of y over x. Now, sometimes we're going to be doing it in the calculator, so that makes it easier to do on the calculator. So that's another one that we can use to find our theta now. So these three are the ones where you can find rectangular from polar. And now we got to find something with these two things. So what does the SO mean? The SO stands for sine. So sine of theta is going to be opposite over hypotenuse. So opposite over hypotenuse would be what? Y over r. So y, if I cross product, equals r sine theta. So we still have the ca. So the ca means cosine. So cosine of theta equals r adjacent over hypotenuse. So if I put this over 1 and cross product, I get x equals r cosine theta. So there we've got our conversions. So dog ear that side of your notes or something so that we know that we can get back to it. And now we're going to try an example using the formulas. So everybody got it up to this point? Okay. If not, we can pause me. All right, so we're going to go polar to rectangular. So we have the ordered pair 4, 2 pi over 3. And that's going to be our r, theta. Just helps if you can see what I'm writing. There you go. So this is our given thing to us. This is our r, and this is our theta. So what formula gave us something that we could find x and y, having known 4 is r and theta? Well, we had those two about x equals r cosine theta, x equals r sine theta. So x equals r cosine theta would be one of them, because we're finding x. And y equals r sine theta would be my y. Okay? So we're plugging in x equals r, which is 4, cosine theta, which is 2 pi over 3. For y, I'm going to get y equals r is 4, sine of 2 pi over 3. Now, we're not finished at that point. We have to come out and find what cosine 2 pi over 3 is and what sine 2 pi over 3 is. Now, you guys know that from the unit circle. In the unit circle, we would go to 2 pi over 3, which is here, and we would find the ordered pair for that point. So if I drop my perpendicular, this is the short side, this is the long side. So I know it's going to be negative 1/2 square root of 3 over 2 for 2 pi over 3. So you know that already because you know the unit circle. So which one of these is going to be cosine 2 pi over 3 and which one of these is going to be sine of 2 pi over 3? Well, we know that cosine is the x in the unit circle and sine is the y in the unit circle. So this is going to be x equals 4 times negative 1/2 and y equals 4 times square root of 3 over 2. So if I put the 4 over 1, then you can see that the 2's are going to simplify, so that cancels with here, and I get x equals negative 2. And then here the 2's cancel again, and I get y equals 2 square roots of 3. So my ordered pair is negative 2, 2 square roots of 3. So this is my x and my y, this is my r and my theta, and that's they're matching points, if you will. But one thing I would always encourage you to do is I want you to check and make sure that they both are in the same quadrant, because if they're the same point, they have to be in the same quadrant. So that's going to be one way of checking your answer. So this one is negative 2, positive 2 square roots of 3. So where would negative 2 positive? So negative 2 positive is going to be up here in second quadrant, right? So is 4 2 pi over 3 in second quadrant? Well, we said up here was 2 pi over 3, right? 4 would just be 1, 2, 3, 4 out. So that would still keep it in quadrant 2. So both of them are in quadrant 2, so more than likely that's the right answer. Okay? Now that was polar to rectangular, right? So we can't get away without doing a rectangular to polar. So the next one's going to be rectangular to polar. So this one's going to be 2, negative 2. And that's going to be my x and my y. So that's the rectangular, and we're changing that into the polar. So these two on the top ones, when we did the other one, these two both had r cosine theta and r sine theta. So that's not the one we're going to use for this one now. We're going to use that other one that says r equals the square root of x squared plus y squared, because I'm looking for it to be a r comma theta situation that when we get our answer. Okay, so we're going to plug in r equals 2 squared square root plus negative 2 squared. So 2 squared is 4, negative 2 squared is 4, 4 plus 4 is 8, so I get r equals the square root of 8. But we can't leave it as square root of 8 because 8 has a perfect square in it. So r equals the square root of 4 times 2. Square root of 4 is going to come out as 2 square roots of 2. So there's my r. And now I need to find theta. So tangent theta, we said, is going to equal y over x, right? So what I would do is I would decide, in this case, what I'm going to use, right? So I'm going to use my negative 2. Where did I go? Right here. Negative 2, negative 2. So y is negative 2 x over 2. So what does that give me? That gives me tangent theta equals a negative 1. So tangent has to be negative. Now we have to decide, here's my 2, negative 2, and that's what I'm converting it to rectangular now. But what quadrant is this in? 2 to the right and 2 down is going to give me where? Okay, quadrant 4. So let's see if that works. So I go 2 to the right and 2 down would give me quadrant 4 then, right? Down here. This would be the x-axis, this would be the y-axis. So we know that we have to have our answer in quadrant 4. So what value in quadrant 4 is sine and cosine the same thing? Because this is the same thing as saying sine theta over cosine theta, right? So we're trying to find out where it's equal to -1. So I heard someone say negative pi over 4. So negative pi over 4 equals theta. That's one possibility, because that puts us in the 4th quadrant, right? Negative pi over 4. But we have, in this case, we have another choice too for negative pi over 2, or -1. We're looking also at what? Up here in 3 pi over 4, right? Because that would be -2 as well. So our answer is going to be, is this negative or positive? This is positive, okay? So our answer is going to be 2 square roots of 2, because that's our r, and our theta could be negative pi over 4. Or, what did we say the other one? It could be negative pi over 4, or we said it could also be -2 square roots of 2, comma, 3 pi over 4. So let's see if that works. So we said that our point was 2 square roots on negative pi over 4. So here's negative pi over 4, and we're going out to whatever 2 square roots of 2 is. We're just getting an approximation. Okay, so where would this be? Well, this 3 pi over 4 is going to be like that. So instead of coming up to this point, like we would do, they went to 3 pi over 4 and went backwards on it. So yes, that one would work too. So like I said, you can have a whole bunch, and you get an infinite number of them. So let's just circle one to make sure we know we had one. All right, so that's all the time we're going to put on polar to rectangle and rectangular to polar. But make sure that you check the very end to make sure that they're in the same quadrant, okay? All right, the next thing we're going to do is we're going to convert some equations into rectangular and polar. So we're going to grab one of those graphs so we don't have to always draw our own graphs, and we're going to grab our straight edge. Okay, the first one we want to do is to graph. I guess we're not on the graphing part yet. I'm sorry, we're on converting, so we'll put that over to the side still. We're going to convert from an equation this time. From rectangular to polar. Now we're using those same conversions that we had a few minutes ago. So we've got x squared equals 4y. Now, x squared equals 4y is a rectangular because it's made of x and y's, and we're changing it to polar, so we want to get an r comma theta. So what formula can I plug in for x to make it turn into r comma theta? X is r cosine theta, right? Now, notice I have to square it, though. R squared cosine theta squared. And over here, what am I putting in for y? I'm putting in r sine theta, right? So r, I got a 4 in front, r sine theta. So now I have r squared cosine squared theta equals 4r sine theta. But what are we doing now? We're solving for y. Or excuse me, we're solving for r in this case, because normally we would solve for y if we were in rectangular, but now we're solving for it in polar. So the next thing I'm going to do is I'm going to divide by something, because I want the r to be just r. I don't want it to be r squared. So I'm going to divide both sides by r cosine squared theta. As long as I divide by the same thing, r cosine squared theta on both sides, it's still going to be an equivalent expression, right? So now r squared and r squareds cancel out over here. And one of the r's cancel out, so I'm just left with r equals. But this side's a little harder to see, but what we have is 4 over 1, and then we have r over r, but that's going to go away. And then we have sine theta over 1 of the cosine thetas, and then we have 1 over cosine theta. Does everybody see where those came from? We're just breaking this apart. 4r sine theta, 4r sine theta, r cosine squared theta, r cosine squared theta. So the 4 is just going to come down as a 4, but the r cancels out to be a 1, and the sine theta becomes a tangent theta, and 1 over cosine becomes what? Reciprocal function, so that's going to be my secant theta. So there would be my polar form of that same equation. So we're okay on that one? All right, the next one's going to be easier than that. This one again is from polar to rectangular. Okay, so this one says r equals 5 secant theta. So we've got an r and we've got a theta in here. But what is secant theta equal to? Okay, I've got r equals 5 times 1 over cosine theta, right? So I can put this over 1, and I could get it to be r over 1 equals 5 over cosine theta, right? So if I cross product, I'm going to get r cosine theta equals 5. So what does your conversion tables tell you for r cosine theta? R cosine theta is going to be x, and then we've got x equals 5. Now, how would I graph x equals 5? Now, what have I told you? What words did I say to use when you're talking about x equals 5? What axis am I cutting? So I'm cutting the x-axis. Where am I cutting it? At 5. So I'm going to go 1, 2, 3, 4, 5, and I'm going to have a vertical line for x equals 5. If I wanted to plot a y equals, then I would go the other direction, right? So we're okay with this one? All right, so the next thing we're going to do is we're going to convert some more equations. Probably do a couple more. So let's try r equals 2 sine theta. Okay, so we're going to try to figure out some way to get the r's and the thetas to go away. So we know that we have an r, but we don't want to square root of something, so we're going to try to make this an r squared. So we're going to multiply both sides by r. So we're going to parentheses r on this side, parentheses r on this side. So as long as we do the same thing to both sides. So we started with r equals 2 sine theta, and now we're multiplying by r on both sides. So this gives me r squared equals 2r sine theta, right? Now, what is r sine theta? Do we have a formula for r sine theta or anything like that? So we go back and look at our formulas. We have x equals r cosine theta and y equals r sine theta, right? So this is going to come out to be 2y, because that's what r sine theta is. But what does r squared come down to be? R squared was that Pythagorean identity, right? So we get x squared plus y squared equals 2y. So now we realistically are in rectangular from polar. So this was polar, and this one is rectangular. But we see that this is an x squared and a y squared, so that's something that we can graph easily. So we're going to go ahead and we're going to rewrite this as x squared plus y squared minus 2y equals 0, because we're going to bring the 2y over. So I'm at x squared plus, now this one we have to complete the square on, so minus 2y. So what does the rule say? Half of b and square it. So half of 2 would be 1. 1 times 1 is 1. So I've got a plus 1 here and a plus 1 on the other side. So this gives me x minus 0 squared plus y minus 1 squared equals 1. So does anybody know what that equation looks like? X minus h squared plus y minus k squared equals r squared. Do you remember that from Algebra 2? This is a circle. So we're going to see how do we graph that circle. So we're going to go up here and we're going to graph. The h and the k gives us our center. So h is 0 and k is 1. So I go up here to 0, 1. And I plot my center. And then r squared is equal to 1. So that says that r is equal to 1. Take a square root on both sides. So our radius is going to be 1, so 1 all the way around. So it looks something like this. So notice one thing that you want to take into consideration right now is that the radius is 1, so radius is 1, and we also know that this circle around here is wrapped around the y-axis. And we know the y-axis is the sine. So that's why this one looks a little different than some of the ones we're going to look at later. All right, so we've gotten fairly far in this section. We'll probably do some more later. But next thing we're going to do is we're going to look at that graphing of polar equations. So we're going to grab the graph again. And we're going to use this one right here so we can have a little space to draw underneath it. So this one is pretty straightforward. It says to graph r equals 3. Now, when we say graph r equals 3, you're basically saying, doesn't matter what theta is, I just want you to go r equals 3. So every theta on here, I could say r equals 3. So r equals r theta, if r equals 3, then you could say 3 comma pi over 2. So 3 comma pi over 2, I'd go to pi over 2 and I'd count out 1, 2, 3. Okay, but I can keep doing that. I can do that on all of them. I can say pi over 6, 3 comma pi over 6. So at pi over 6, I'm going to go 1, 2, 3. And this one, I'm going to go 1, 2, 3. And this one, I'm going to go on 1, 2, 3. So what do you see happening there? If I get enough of these together, then it's going to form a what? A circle. So there's my circle from all those r's. So that would be what r equals 3's graph looks like, would be a circle. Now, if I wanted to change that back into a rectangular one, then I would have the idea of r being the square root of x squared plus y squared. So we're okay on this one, just forming a circle. So r equals 3 is a circle. Now I could have given you r equals 2 or r equals 1. It still would have been a circle. Okay, the next one we're going to look at is theta equals pi over 3. Now again, pi over 3, we can see pi over 3 is, looks like right up here. Okay, so there's pi over 3. So what does this say? It says, I don't care what your r is, I'm just going to have theta be pi over 3. So no matter where I do it, I'm doing theta equals pi over 3. So if this is pi over 3, that's not pi over 3, this is pi over 3. If this is pi over 3, then I can put a dot. Well, down here, that's pi over 3 too, so I can put a dot. I can use my ruler, and I can jump across the board, and I can put a dot. Now, why can I put them down here? Well, these are the negative side, right? So if I find this one to be a positive 2, I'm going off this direction. There's still going to be pi over 3 with positive 2, pi over 3 with 3. Here would be pi over 3 with negative 1, negative 2, and so forth. So we're just going to draw our line in. So everywhere on that line, you're going to have pi over 2. Okay? So that one would be a graph of a line. So we feel comfortable with that one. All right, so now let's get a little bit more serious. So the next one we're going to look at is up here. I'm going to fold the paper though. All right, so the one that we're going to do looks like this. R equals 2 sine theta. Let's don't do that one. Let's do R equals 2 plus 2 cosine theta, because that was the same as this one up here. So we're going to do R equals 2 plus 2 cosine theta. We're going to graph it. Okay? Now, they're going to give you in your textbook a picture page with a whole bunch of pictures of graphs. And so this one right here is going to be an example of what we call a cardioid. Okay? It has a little shape of a heart. So we have this thing where we're going to graph. So we're going to move down a little bit. There we go. All right. So when we graph this, you can do it several different ways. One way is to just do plotting points. Okay, so we're going to plot some points. And then we're going to decide what it's starting to look like, and then we can go ahead and use symmetry after that. So if I look at the heart shape equation to see what it basically looks like, it basically looks like R equals A 1 plus or minus cosine theta. So if I look at this one, I can make it look almost the same by taking the 2 out. So 2, it would be 1 plus 1 cosine theta, because I took a 2 out, right? So now it looks like this. So this one is the form, the basic form for a heart-shaped figure, right? So heart-shaped. And what do we call it? We call it a cardioid. Okay, so a cardioid has a little shape that looks kind of like this. So it does look kind of like a heart. So I'm going to use an XY chart. So I've got an XY chart. Now, it's not really XY chart. It's really an R theta chart. So we're going to make it R theta, because we're going to be plugging into this formula right here, the one that we took the 2 out of. And we're going to plug in some of the stuff that we know, so we have to be really careful to make sure we know what we're doing. So we're going to plug in for what? We're going to plug in for theta this time, and then it's going to tell us what R is. So our theta is going to be 0, pi over 6, pi over 4, pi over 3, pi over 2, and then we're going to stop there for a minute and try those. So let's go ahead and do pi 0. So we're going to plug in 0 for what? We're plugging in 0 for cosine, right? So this is going to be 2 times 1 plus 1 cosine of 0. Now what do we know about cosine of 0? Well, cosine of 0 is going to give us positive 1, right? So cosine of 0 is positive 1, times 1 would give me 1. 1 plus 1 is 2. 2 times 2 gives me 4. So this is equal to 4. So I come up here next to 0 and I put 4. Now we can graph it as we go along, or we can wait until we've got all of them and then put them on the graph. So that's probably the easier. So the next one we're going to do the same way. 2 times 1 plus 1, but we're going to have cosine this time of pi over 6. So pi over 6, we know what pi over 6 looks like on a unit circle, so you could even get your unit circle out if you want. There's pi over 6. So what am I going to do with that pi over 6? We're going to put it into the formula, and we see that cosine pi over 6 is going to be the x value. So that's going to give us what? Square root of 3 over 2. So I get 2 times 1 plus 1 square root of 3 over 2. So this is going to give me with a calculator. So we go to our calculator on this one. And pi over 6 is going to come out to be 3.7. So you get the idea. We're just plugging these numbers in. Pi over 4, you're going to find out what it comes out to be. Pi over 3, pi over 2. So we're going to go ahead and tell you what those are so we don't keep you too late. 3.4, and then pi over 3 is 3, pi over 2 is 2, and this last one, 2 pi over 3 is 1. Okay, so now we're going to go up and we're going to graph. So you got to remember, theta is the angle, r is the point, right on that line. So the first one we're going to do is 4, 0. So we don't go out anywhere. So let's get the ruler out and let's kind of line it up here. So my 0 point is right there. Okay, here's 0 and here's pi. So it says for you to graph on the 0 angle line, positive 4. So that would be 1, 2, 3, 4. So there'd be a dot right here. Okay, you agree with that dot? All right, the next one is pi over 6, 3.7. So this pi over 12 is not what we want. We want to keep going to the pi over 6. So that's the pi over 6. So at pi over 6, we're going out 3.7. So 1, 2, 3, 4. So that's too high, so we're going to come back 1. And obviously, these are not really accurate, but at least it gives you the idea. Then the next one's pi over 4. So that's pi over 4. And at pi over 4, it says 3.4. So 1, 2, 3.4. Pi over 3. So we're going to go around to pi over 3, which would be, looks like right here. So at pi over 3, then we have positive 3, so 1, 2, 3. And pi over 2, here's pi over 2 up here. Pi over 2 says you got to go up 2, so 1, 2. And then the last one that we have done so far is 2 pi over 3. So 2 pi over 3 is right here. And it says we're going out 1. So here's 1. All right, so do you kind of see a little bit of a cardioid forming? See how this comes around like that? How I told you it was going to look? So what we can do is take these points that we have on this side and reflect them across the 0 to pi line. So this would be my symmetry then. So I would go from here. All of these dots, except for this one, would go flipping to the other side. Okay? So we're going to have to carefully do that. So the next one would be right here, and you went down just a little bit, right? So there would be that one dot. And then the same thing with that one. We're going to the next opening, and we're down just a little bit. So this one would be that one. And then we're down to this one, right? So just a little bit below. All right, so go ahead and get your dots put in, and I'll see if I can get my dots put in. So this one's up here. And then this one is a little closer. And this one is, and then we have there, and we have there. All right, so when we draw them in, it's going to look something like this. Okay, so you have your cardioid, I should have brought some pencils to color them in for you. So that would be my cardioid. Can you see it in the blue? So after we get this part, then we just flip it over and get the other half. Okay? So the next one we want to look at is the 3-leaf rose. Now again, we'll be doing some more of these kind of things as time goes on. Leafed rose is what they just call it. Leafed rose. Now the leafed rose uses a lot of symmetry, meaning that it looks the same on both sides of something. So it might look something like this, where you've got your little leaves going like this. That's one way it could go. You might have one that goes like this. That would be another way it could go, right? It still has 4 leaves. But when we look at our formulas for the leafed rose, we get R equals A cosine n theta, and then R equals A sine n theta. Okay, so now the A and the N stand for something, right? So what the A stands for is the length of this petal. So the length of this petal is going to be whatever A is. The N determines how many leaves you have and whether it's going to be even or odd, okay? So the graph says that if it's N, then that's how many pieces of, how many leaves we have, if it's just N. But if it's an odd number, if N is an odd number, then it's going to be just N. But if N is even number, then it's going to be twice as many. So let's rethink that again for a second. The graph is an end-leafed rose, and if N is odd, then that's the number of leaves that it has, okay? But if N is even, then our number of leaves is going to be times 2. So 2 times N. So let's look at the one that we're going to try. I'm going to do that on a separate sheet of paper. So we have R, we're going to graph. R equals 1 cosine 2 theta. Okay, so we had those two equations. We said that we had R, let's see if I can get it on there, A cosine n theta and A sine n theta. So in my case, I'm going to have R equals A cosine n theta, right? So now we have to determine which way is it going to go. Is it going to look like the one that goes flippity-floppity? Right. So A is 1 and N is 2. So if N is even, then what do you do with the number of leaves? If N was even, we said to do what with it? To times it by 2. So we're going to get N equals 2, which is even, times 2 gives me 4 leaves. Okay, is everybody okay? And where we got the 4 leaves from? If you go back and read what it says about it, it says the graph is an end-leafed function, rose. If N is odd, then it has that many, but if N is even, it has twice as many. Okay? All right, the next thing we're going to do is, now that we know it has 4 leaves, we're going to draw a picture of it. Now, my picture is going to take into consideration that this A equals 1. That's how long my leaves are, so length of leaves. So when we draw the picture, we're going to make it come out a little bit different. So we're going to use this as our picture. Let's see if it has enough. 1, 2, 3, 4. Yes, it does. All right. So in our working stuff out, we've come out with the fact that it has 4 leaves. And how long are the leaves? The leaves are 1, right? So when I do my graph, what I'm going to do is, instead of starting here and letting that be my graph down here, I'm going to bring my 1 back up here. So my 1 is going to start here. This would be 1 3/4, 1/2, 1/4, none. Okay? So that's how we're going to use this graph. This is going to be the 1, but this is 1, 2, 3 different pictures as we go down. Okay? It'll make more sense here in a second. So we get r comma theta again. We're making ourselves a chart. Now we don't need a lot of them because we can start paralleling those leaves after we get them. So we're plugging in for theta. So we're going to plug in 0 for theta. We're going to plug in pi over 6. We're going to plug in pi over 12. And we're going to plug in pi over 4. So let's see what we got with those. So if I plug in 0, looking up here, 2 times 0 is still going to be 0, but cosine of 0 is 1, right? So I get a 1 right there. Because we're plugging in 0, 2 times 0, cosine of that. So what about pi over 6? So we're going to look at pi over 6 on the unit circle. So here's pi over 6. What's cosine and what's sine? You got cosine of n times theta. So we got pi over 6 now we're considering. Any ideas? All right, so we're going to go ahead and look at pi over 6. Pi over 6 we're going to plug in. So n, we don't know what that is. So theta, we're going to put in pi over 6. Cosine of pi over 6 is that square root of 3 over 2. And then our a is going to be what? Our a is 1. Okay? So pi over 6 comes out to be 1/2. Pi over 12, we plug it in, and we're going to get 0.86. And number 5, pi over 4, we're going to get 0. Okay, so everybody got those written down? So now we're going to graph them, see what it does for us. So I get 1, 0. Now, that would be this one right here, and 1, 0 is going to be this dot right up here. I'm going to try to make them pronounced so you can see which dot's there. All right, so then we're going to plot the next one. The next one is 1/2 pi over 6. So where's pi over 6 again? Pi over 6 is right here. So we're going to go 1/2 on it. So we're dropping back, and this is going to be the pi over 6. So I go pi over 6 is going to be going to 1/2. So where's 1/2 going to be? Pi over 6 and 1/2. Well, we're going to come down here because the whole thing to here is 1. Then 1/2 would be 2 up, right? 1, 2, 3, 4. Yeah, 2 up. So pi over 6, pi over 4. Pi over 6, I think what we were saying. Okay, so this one right here. So we'd go 1/2 right there. Okay? The next one then we had, after pi over 6, we had pi over 12. So pi over 12 is back in between here. So we have 0.8. So 0.8 would be up in this region. So we're going to go up a little bit. And then pi over 4 would be back to 0 again. So pi over 4, you're going to be right here to 0. So look what's happened. This has gone into like a leaf. Now we know these leaves are symmetric, right? So this one's going to come over here. This one's going to come over here. And then you just finish out your leaf. So as long as you have 1/2 of it, then you have the whole thing. So then you do your next leaf and your next leaf all the way around. So you see the leaf right here? Okay. The next thing I want you to do is I want you to look on page 600 in your book, if you can find page 600 in your book. And they give us some equations and they give us some pictures. So ours is going to look something like this. Now I included the answers so that way you can see the answers too, but try to maybe cover up the answers until you've done them. So this is the way it looks. So you have to match these with what these are, okay? Now, if we go back to the ones that we've already done, there's certain format I told you that it was going to look like when you graph it. So this one has the A cosine n theta, which would be our circle, right? This one then says, what do these all look like? Well, I would pick the ones that I knew first. What do we know about r equals 3? Do you see one of these graphs, these 6 graphs, that would be the equation of r equals 3? Doesn't matter what your theta is, the theta doesn't matter. We're looking at r equals 3. So which one is r equals 3? Where does 3 go out from the center all the way around? Anybody see it? R equals 3. What about this one right here? Would that be r equals 3? Because you're going out 3, 1, 2, 3, 1, 2, 3, all the way around. Okay, number 5 is one we just did, right? So what did we get 5 to be? What is 5 supposed to be? Which one of these pictures is, which one of these is going to be like 5? That's what I was going to try to ask. 5 goes with what? If it was one that I just did, what did one I just did look like? Not that page. Just see what page I was on. This one right here. What did we call that right there? Cardioid, right? So that's what that one would be, number 5. That would go with 2. So I want you to go to that page and see if you can match up these equations so that way you know which one goes with which one, okay? This would probably be another circle. It's on the x-axis now, and we've got a cardioid and a lemnicon, and so we got a lot of different stuff you can look up. Okay, let's see how much more we want to do tonight. We're going to look at one last one. This is number 42. Number 42 says r squared equals 4 sine 2 theta, and we're going to graph it. So this one's pretty straightforward to graph, but let's first talk about it a little bit. We have a formula that says r squared equals a squared sine 2 theta. And we have another one that says r squared equals a squared cosine 2 theta. So we're going to try to find out the difference between these two things. So let's kind of make a mark between there. This is called a lemniscate. Lemniscate. N-I-S-C-A-T-E. Okay. So an lemniscate looks a little bit like an infinity sign. The one that's with the sign is going to look like this. And the one that goes with the cosine is going to go like this. Like I said, it kind of looks like an infinity sign, right? The A is the length of the leaf. So here's my a squared. That A would just be the length of the leaf. Okay, so let's see what this one does. We know it's on sine, right? Sine 4 is going to give me A is 2. So A is equal to 2. So now we're going to, excuse me, put some numbers in. So I get r squared, and I'm plugging in, looks like pi over 4. Now, why would I pick pi over 4 to start out is because of the way that this is graphed. See how this one would be on pi over 4, and this one would be on pi over, this would be on 0. So we're going to have r squared equals 4 sine 2 times pi over 4. Okay, so you agree with that? If I put the 2 over 1, the 2 and the 4 are going to cancel, and I get r squared equals 4 sine pi over 2. So what do we know about sine of pi over 2? Well, sine of pi over 2 is up here on the unit circle, so we know sine is going to be 1. So I got r squared equals 4 times 1. So if I take the square root on both sides, I'm going to get r equals plus and minus 2. So there's my plus and minus 2. We said that it was going to be 2 for the length of the leaf, right? So now, basically have it. You're just going to go to the graph. Let's get one of the prettier ones. All right, so we're going to graph pi over 2, except this is not x and y, this is r and theta. It's actually theta and r. We need to have some white out, don't we? Okay, so this is going to be r and theta, but our plus and minus 2 and our pi over 4. So we're going to use our straight edge again. Pi over 4 would be here. So we're going to have plus and minus 2. So it's going to go out 2 here. It's going to go down 2 here. So it looks like this is going to be one of the ones that's on the diagonal, right? And then we just try one more point. It comes down to about here, and then we can parallel it over. So my graph looks something like this. And then you can kind of color it in if you want to make it where it's easier to see. Okay? All right. Your homework on this is going to be page 600. And we're going to graph numbers 21, 23, 24, 25, 29, 33, 39, and 41. Now, when you graph these, I want to see where you substituted in. I want to see your charts. I want to see where you've written them on the graph. So be specific when you're doing these. Thank you very much.